Good morning, Amethyst team. It's a lovely sunny day in Melbourne. I'm hard at work on the Fumed Silica pump that we've been talking about, and I'm just about to give you a demonstration of how it works. So here's the prototype. As you can see, it's a very precision built, German engineered type piece of equipment. We have our squeeze pump, which is actually a hinge on a piece of board, which goes down. If you apply a force, it actually squeezes the rubber hose. Over here we have a valve, which is the inlet valve. It's sitting on a little pin at the present moment. If we rotate it slightly and lower it down, it actually pinches the hose and performs a valve action. On the opposite side of the squeeze pump is a similar valve, which is the discharge valve. During the operation of this particular pump, at no time will both valves be open, so there is no possibility of passage of gases either direction when the plant is running. The red ball that we see here is actually our nitrogen injection system, but in this case we're just using a little bit of compressed air by activating the squeeze ball. And over here is the fumed silica in a glass jar, and ultimately we're hoping to pump it into this receiver over here. So that's basically it. This machine is very simple and obviously manual in operation, but we would replace all of these manual steps with either solenoid or air-driven linear activators, air rams. Anyway, let's see if we can make it all work. Okay, first step is we insert the tube into the fumed silica, give it a bit of a swirl around so we've got it fully covered. That's okay. Next step is we close the intake valve. The next step is we close the squeeze pump and we just apply a small weight to keep it closed. Next step is we close the exhaust valve. Then we open the intake valve, and if we come and focus a little bit here, come in a little, you will see fumed silica being dragged up that tube. Okay, the first step of the pump is that we have the intake valve closed. We then compress the rubber hose to expel air. We then close the discharge valve. The next step is we open up the pump to provide suction, and we will then open up the intake valve. Now if we look carefully, we'll see fumed silica sucked up the tube. So you can see at the present moment the fumed silica is about here. So it will take a number of cycles to put the fumed silica right through to this region here. So we will commence with that. So we close the intake valve, open the discharge valve, apply pressure to squeeze the hose. We then close the discharge valve, open the pump, and again open up the intake valve, and you'll see the fumed silica rush up the tube. So we've now made the fumed silica to about this point here. So about one more cycle and we will have it right through. So we close the intake valve, open the discharge valve, compress the air out of the pump, close the intake valve, discharge valve rather, open the pump, and we again open this up and it will bring fumed silica through to here. So now the pump is more or less probably primed only to about this mark. So the next step is we close the intake valve, open the discharge valve, and here now we wish to blow the line clean. So we will just give this pump a little squeeze and hopefully fumed silica will end up in this chamber here. No, not quite yet, because we haven't quite got enough fumed silica. So one more cycle. So we close the discharge valve. Sorry, we don't do that. We close the pump, close the discharge valve, open the pump, open the intake valve. Right, now we close the intake valve, open the discharge valve, and give it a small squeeze of air and see what happens. And there you can see the fumed silica has entered into the receiving chamber. And again, we just repeat this cycle time and time again, and at no stage do we have fumed silica in the line, so we don't do any actual compression. And that's basically the system and how it will operate.